Hi everyone, today we are gonna look at this Leetcode problem. It's called rotate list. So I will jump right away to the description. We have been given head of linked list, and what is expected from us is to rotate it by k places. K can be anything from 1 to maybe several millions. So it means that even k, for example, has 5 elements. K can be 25 or like 32 or even like a 5 million. So what does it mean? It means that we need to find an efficient solution. The first thing is that we have been given an example also. If you see here, for this linked list, if k is 2, it means that every element will shift to the right 2 places. So this will be new head, and this will be second, and this will be last element of linked list. And we can also see here at the final step, because k was 2, so 4 became head and 5 became second node, and in the same way third is last node of new linked list. So you know what does it mean. We need to rotate it k times to the right. So now we looked at the example where k is less than the size of the linked list. At the moment it is 5 for this example, right? So k means that how many places element will shift to the right, each element. So here we said that k is 2, that's why every element shifted 2 times to the right, including this one, this one, this one. So that's why this became new tail, as you see here. So this is last element of the linked list. But what does it mean when we have k is equal to 5 for this example? It means that every element will shift 5 places to the right. So that means that we will have exactly the same linked list again, because 1 shifting to the right 5 places, it means that it will come back to its own place. It is the same for each element in linked list. So our takeaway from here is that if k is equal to size of the linked list will be the same. But what if k is greater than the size of linked list? So let's say k is 13. So we can see that actually we can take modular operator from here, and we will see that the result from this operation is 3, right? Because it is 13 is equal to 2 multiplied by 5 plus 3. This we don't count, right? Because we said that if each element is moved by 5 times for this example, it means that we will have the same linked list. So we will remove this one. This has no effect. So that means that we will only try to see which linked list we will get if we shift the elements by 3 places to the right. So that's the whole idea. And how we will do this solution, I will show it to you on this whiteboard. For this example, k is equal to, that we already know. So if k is 2, every element will shift 2 places to the right. So 4 will be new head, as you see here. So the solution is not that difficult actually. We need to break this connection between 3 and 4. So that means that the next node of 3 will not be 4 anymore in the new linked list. And the next thing is that the next node of 5 will be 1. So if you pay attention carefully, this is actually the same as the first linked list. 4, 5, 1, 2, and 3. It is the same sequence here in this linked list. How we can do it programmatically is, we can first try to connect this node together. So the next node of 5 will be 1. So in this case, we will create a loop in the linked list. And the next step is, we will break the connection between 3 and 4, and that's it. Actually, it's also easy. The next node of 3 will be null instead of 4. That's it. Let's jump to write the code for this logic. The first base scenario is that actually linked list can be null empty, or k can be 0. So that means that we will not move any elements to any place, right? So in that case, we can handle first that scenario. So if head is equal to null, or if k is equal to 0, we will just return head itself, so linked list itself. And then what we need is to find the size of linked list, right? So for that, we need just to have one variable, and then we will write head to the current node, and to find the size of linked list, we will use this common approach. The approach is that as long as next node of current is not null, it means that we will go through the linked list until the last node of the linked list. So in this case, we will also process 5 and then we will stop. So as long as next node of current node is not null, we will calculate the size, we will increase the size, and we will update current to the next node of the current. So we will move one element to the right. So that is traditional and common approach that you can use to calculate the size of linked list. And after we have the size of linked list, so we know that we have 5 elements, for example, in this linked list, we can try to find number of rotation that we will do. And you know that why we are doing this. I will tell you again. So we said that k can be more than the size of the linked list, right? So k can be 13 and size can be, for example, 5, let's say. So in this case, we said that we don't need to rotate the linked list that many times. We can just find the module operation of k and size, and then we can say that, okay, this will move, the number of rotations will be only 3. So we need one node that we can call tail, the first part of the linked list. So it means that in this example, from 1 to 3, in order to store this 1 to 3 linked list, that part of the linked list, we need to have one variable. So we will call it tail, and it will be equal to head of linked list. And we will go through the for loop. We will start from 1 because we already have the first node, so that's why we don't start from 0. And it will go until size minus number of rotation. That means that if size is 5 in our example, and number of rotations that we need to do is 2, and we will go through the for loop 3 times because size minus number of rotation is 3. So we will try to arrive at the node with the value 3. So it will be tail is equal to tail.next. So we will arrive at node 3. So we said that new head will be 4, which is just one node after the last node of new linked list. So last node of new linked list will be tail, which is 3, and the new head will be next node of that linked list. So now after we find the new head, we will say that next node of 3 will be null. So we will cut that connection. So we did everything, but the only thing that we have forgotten is to create that loop in linked list. So to create that loop in linked list, we can say that the next node of that current element, which is 5 at this point, at this example, will be head. So now we have circle in linked list. So there is a connection between 5 and 1. So that's why we have created linked list circle. I think that should be it if we haven't forgotten anything. Let's run for the example input. And we have missed something here, of course, yes. Okay, we have one failed test scenario, and let's see what's happening. Okay, instead of starting with 4, we are starting with 3, and I think that is because of we have calculated the size in the wrong way. Okay, because we are starting with head, it should be size 1, so not 0, because we have already processed head. And let's see how it goes. Okay, now both of the examples passed. Let's submit. Perfect. So it is 0 millisecond and it beats 100% of the solutions. That was it for today, guys. And if you like my videos, don't forget to subscribe, like, or comment in the comment section. See you in the next video. Take care.